Here the frisbee, which was initially at rest, now it is in motion and it again comes back to rest. When some external force is applied on a stationary rigid body, then the body moves along a straight line path in the direction of external force, and such a motion is known as linear or translational motion. When a rigid body is pivoted at a given point and some external force is applied on it at some other suitable point, then the body rotates about an axis passing through the pivoted point. This type of motion is known as rotational motion. Here, the rotation of Earth about its own axis is an example of rotational motion. And in this lesson, we will learn about moment of force. When some external force acting on a body has a tendency to rotate the body about a given fixed point or about a given fixed axis, then this force is said to be exerting a torque on that body. Thus, turning effect of force is also known as moment of force. And now let us understand a rigid body. When an external force acts on a body and the distance between the 2 points on the body does not change, then the body is known as a rigid body. Now let us consider a rigid body which is pivoted at point O. When some external force F is applied on the body horizontally such that its point of application is P, while line of action of force is along AP, then this force will not be able to produce any linear motion because body is pivoted at point O and is not free to move. However, this force rotates the body about a vertical axis which is passing through point O in anti-clockwise direction. Now, this force is said to be exerting a torque on the body. And now, in order to open a door, some external force is applied on its handle so that the door turns on its hinges. The greater is the external force, larger will be its turning effect. It is also found out that it is easier to open the door when external force is applied near the end than near the hinges. It means turning effect of force is greater when its distance from its axis of rotation is greater. Therefore, moment of force is the product of the magnitude of force and the perpendicular distance between line of action of force and axis of rotation. And now, let us discuss about clockwise and anti-clockwise moments. If the applied force has a tendency to rotate the body in anti-clockwise direction, then torque is taken as positive. And if the applied force has a tendency to rotate the body in clockwise direction, then torque is taken as negative. And now let us look at some common examples of moment of force. Opening and closing a door, while using a hand flour grinder, while turning the steering wheel of a vehicle, while using a spanner to tighten or loosen a nut, and while riding a bicycle. A couple is formed when two equal and opposite parallel forces act on a rigid body along different lines of action. For turning the key in the hole of a lock, a pair of forces is applied. The moment of a couple is given by the product of the magnitude of either force and the perpendicular distance between the two forces. Now let us understand the equilibrium of a rigid body. Static equilibrium. When a body remains in a state of rest under the influence of two or more forces acting on it, then it is said to be in a state of static equilibrium. And in the case of this aeroplane, we can see when a body remains in same state of translational or rotational motion under the influence of two or more forces acting on it, then it is said to be in a state of dynamic equilibrium. The same we can observe when negatively charged electrons revolve around the positively charged nucleus on a circular path. Principle of moments states that if a body is in a state of equilibrium, then the algebraic sum of moments of all the forces acting on the body about the fixed axis of rotation should be zero. Thus, from principle of moments, we can conclude that in equilibrium condition of a body, sum of the anticlockwise moments is equal to the sum of clockwise moments.